Good afternoon, this is Schweitzer. We're going to run through a pretty short little video here on how to calculate the pH of a strong acid. And really, how do I model and what is a strong acid? So, first of all, a quick reminder here is what is a strong acid? A strong acid is an acid that goes 100%, okay, to completion. Another example, or way they would describe it, would be it ionizes 100%. So that means when this reaction runs, what is the pH of a 0.1 molar HCl solution? So the reaction is, really what makes it strong is H plus HCl plus water will produce H3O plus ions and Cl minus ions. Keep in mind we sometimes call it H plus. So what would happen here stoichiometrically? Well, the water's in excess, so we're not going to worry about the water. It's also a liquid. Either way, it's minus 0.1 to 0, plus 0.1, plus 0.1, and 0.1 and 0.1. We had none to begin with. So, in this case, what's my pH? Well, I know that the negative log of this concentration will give me my pH. So the negative log of 0.1 equals what? And you can grab your calculator, and you should hopefully know already, just based on some of our relationships, that is 1. So my beaker in the end, afterwards, my after beaker, what's that going to look like? Well, it's just going to be H plus ions and Cl minus ions. And the more you draw, just the more concentrated you get, depending on what you start with, the more you end with. Now, in this case, so here's my answer key here, and there's that guy, and then we have this one located right here. And notice how this line, it's because it's a strong acid, then these will always be equal, always. So, with that being said, we could make a temporary little algorithm only for strong acids, mind you. Okay, strong acids only, and that's going to be H negative log of the strong acid concentration gives you the pH. Now, this only works for strong acids. Okay. So with that being said, how do we model a strong acid? Again, let's try it again here. Just this guy here, that's my products. Only going to draw products because it goes all the way to product. It's going to be just X negative H3O plus. That's the dilute version. The concentrated version would be X negative H plus X negative H plus X negative, however many you like drawing. Now, one thing I mentioned, that the algorithm I just mentioned only works for strong acids. How do we know, and I'll mention this again later, but how do we know what a strong acids are? Strong acids. All right, we're looking at HCl, HBr, HI, HNO3, H2SO4, and HClO4. You can look the names up if you'd like, but this is hydrochloric, hydrobromic, hydroiodic, nitric acids, sulfuric acid, and this one is perchloric acid, probably one you're not as familiar with. And we will stop our little demonstration here for modeling and calculation of pH of strong acids, and it also works for strong bases. But please move your workbook to become more proficient. Thank you.